Hi everyone, this is Dr. Nak and we're going to go over section 3.6, Graphs of Functions. Okay, so from the last section, let's recall that a relation becomes a function if for each x value there is exactly one y value. So in this section, what we're going to be learning is giving a graph to determine whether the graph is a function or not. Okay, so let's look at the first graph. Okay, so first of all, let's recall that a relation becomes a function if for each x value there is exactly one y value. So let's take a look at this. So here is our x equals to 1. What is the corresponding y value? So the corresponding y value looks like negative 1, 2, 3. So this is 1 comma negative 3. Okay, now let's look at when x equals to 2, corresponding y value is going to be negative 2. Okay, so now let's take a look at maybe when x equals to 3. So it looks like when x equals to 3, our y value is going to be 0. So it looks like for each value of x, there's going to be exactly one y value. Therefore, this graph defines a function. Now let's take a look at graph number 2. So let me just pick when x equals to 2. What is the corresponding y value when x equals to 2? Well, I'm going to do the same thing. So it looks like when x is 2, y value is 1, 2, 3, 4, 5. So this is going to be 2, 5. And then also, the graph is defined below the x-axis as well. So when x is 2, our y value is going to be, what is that? Negative 1, 2, 3, 4, 5. Negative 5. So when x is 2, y is negative 5. So here, when x is 2, we're going to have two different y values, namely 5 and a negative 5. So in this case, this graph is not going to be a function. And let's take a look at another x value. So let me see. Let's go with when x is 0. We could do the same thing. When x is 0, if you go up, we're going to have the y value to be, what is that, 1, 2, 3, 4. And also, when x is 0, our y value is going to be negative 4. So when x is 0, we're going to have two y values. So this is not going to be a function. So I'm just going to write not a function. Okay, so here comes the theorem. The vertical line test. It says that if any vertical line intersects the graph in more than one point, the graph does not represent a function. Okay, so in this, the graph number 1, no matter where I chop it off, or I should say, no matter where I'm going to draw the vertical line, that line is going to intersect the graph at only one point, like here too, right? And then let's take a look at graph number 2. So if I draw the vertical line along this graph, I'm going to go washa like that. Do you see that that vertical line is going to intersect the graph in two places? Therefore, it is not going to be a function. Our next topic is to talk about graph of a function. So the graph of a function is the graph of all its ordered pairs x, comma y, or using a function notation x comma f of x, where y equals f of x. So here, our f is the name of the function. I'll just write name of function. And then our x is the x coordinate of the ordered pair. And then f of x is the y coordinate of the ordered pair. So that's the reason why we call y equals f of x. Let's do some examples. Example 1, graph the function, find the domain and a range, and write the domain and a range in interval notation. So part A, f of x equals 2x plus 5. So let's recall that if you have y equals mx plus b, this is going to be a straight line where m is the slope and b is your y-intercept. What's a y-intercept? That's where the graph is going to touch or crosses the y-axis. So in this case, notice that our slope m is 2, which is same thing as 2 over 1, and our y-intercept is 5. Also, let's recall that slope was defined as rise over run. Okay, so now I think we are ready to graph. So first, let's jot down the y-intercept. Y-intercept is 5, so I'm going to go 1, 2, 3, 4, 5. Oh, the y-intercept 5 means that when x is 0, y is 5. Okay, so now let's deal with the slope. Slope is defined as rise over run. Oh crap, I'm going to run out of the room, I think. So this is telling you from your y-intercept, rise positive 2. So that means that you're going to have to go upward 2 units. And then the run is positive 1. So you're going to have to move 1 unit to the right and then dot it. And then if you connect those 2 dots, that is the graph of the function. Okay, it looks good. So this is the graph of f of x equals 2x plus 5 or y equals 2x plus 5. Now let's go with the domain and a range now. Let's recall that the domain is settable x values where the function is defined. Now let's also remind ourselves that line is infinite, so this tail end is going to keep going upward and this is going to keep going downward. Again, the domain is settable x values where the graph is defined. So let's take a look at maybe x equals to negative 1, 2, 3, 4, 5, 6, 7 or something like that. When x is negative 7, do we have a graph there? Yes, we do. Now when x is, let's see, negative 1, is our graph defined? When x is negative 1? Yes. Okay, now let's take x equals to 2. Is our graph defined there? Yeah, I think so. And remember, this tail end of the graph is going to keep going up and up and up towards infinity, positive infinity. So eventually, if I chose x to be here, it's still going to touch the graph. So that means that the domain is going to be settable real numbers. So meaning, let me just write it down. So the domain is going to be all real numbers. And how do you write that in the interval notation is open negative infinity to positive infinity open. Now let's talk about the range now. Now range is the settable y values where the graph is defined. So now what you're going to have to do is you're going to have to look at the graph from bottom upward. So where does the graph begin if you look at it from bottom upward? We're just talking about the y value. So do you see that since our graph is going to keep going downward, its quote-unquote starting point is going to be from negative infinity. And then since line's going to keep going up and up and up and up, eventually our y value is going to be positive infinity. So our range is going to be all real numbers again. And so we write it as negative infinity to infinity. Don't worry, we're going to do more examples in a minute because I used to have the most difficult time finding the domain and the range given the graph. Alright, so let's take a look at the next one. Part B, let's go with f of x equals 2x squared. To graph this, you can make an x and y chart. Remember this business? X and then the y equals 2x squared. and started plugging in some values. So let's go with when x is -2 maybe, and then let's go with -1, 0, 1, and a 2, and I think that's pretty good. All right, so when x is -2, our y value is going to be 2 times -2 squared. So this is going to be 2 times 4, so it's 8. So what we need to, that's an 8 right there, sorry. So what we need to do is to plot the point -2, 8. So let's go with -2, 8. 6, 7, oh no! 8 is probably right here. Okay, let me just put that in blue. Okay, so now let's go with x equals to -1. Then our y value is going to be 2 times -1 squared, which is 2 times 1, so it's going to give us 2. So this is telling us that when x is -1, our y value is going to be 2. Okay, now let's go with 0. So when x is 0, our y value is going to be 2 times 0 squared. Well, 0 squared is 0, so 2 times 0 is going to give us 0. So we're going to have to plot the origin 0, 0. Okay, now let's go with when x equals to 1, then you're going to have 2 times 1 squared, which is 2 times 1, so it's going to be 2. So 1, 2. Okay, now when y equals to, no, not the y, sorry, when x is 2, our y is going to be 2 times 2 squared. So it's same thing as when x is -2, so it's going to be 8. Okay, so it looks like we're going to have a parabola. Now let's go with the domain and the range. So let me just first write the domain. Okay, so the domain is settable x values where the function is defined. So when you look for the domain, you might want to look at the graph from left to right. For the range, you want to look at the graph from bottom upward. So let's look at this graph from left to right. So notice again that since this tail end just keeps going and going and going, any value of x, so let me see, when x is maybe like -3, if I go directly upward, it's gonna eventually touch the graph. So the graph is defined at x equals to -3. Now, let's take a look at this x value. Now, eventually, if I keep going upward, eventually, since this is a parabola, believe it or not, this is gonna touch the graph. So this is this graph is defined at x equals to, what is that? 4, 5, 6, 7. At a -7. And same thing, when x is +1, let's just say, if I go up, it's going to touch the graph. So our graph is defined at x equals to 1. And if you keep picking some bigger value of x, it's still going to be defined. The graph will be defined. So the domain is going to be settable real numbers. Just going to write all real numbers. And the interval notation is again is -∞ to infinity. So now let's go with the range. Okay, so the range is the settable y value where the function is defined. Always look at the graph from bottom upward when you want to find the range. So where does the graph start along the y-axis? Well, graph starts from y equals to 0, because we're talking about this point right here. So y value is 0. Now, when y is 2, is our graph defined? Yes. And then if you keep going up and up and up, do you see that our graph's going to be defined from 0 all the way up to +∞? So our range is going to be, oops, sorry, not the open, starting from 0. The graph's going to grow towards +∞. So again, you're looking at the graph from bottom upward, and you're trying to find out for which y values that the graph is defined. Don't worry, we're going to do another one. Let me just box this stuff. part C, let's go with f of x equals square root of x minus 1. So again, to graph this, since we're not too familiar with this, so I'm going to make our x and y chart again. So x and then y equals square root of x minus 1. Alright, so now let's start picking some values. I know that we all love to plug it in positive values, but what about the poor negative values? So try to pick negative values if you can, so that you know what the behavior of the graph is going to look like. So again, I'm going to start from -2. Yes, I chose 5 at the end. Okay, so let's go with the y value. So our y value is going to be square root of -2 minus 1, which is square root of -3. Uh-oh. Can that happen? Can we have a square root of a negative? No. So our function is not defined at x equals to -2. Okay, now let's go with when x is -1, our y value is going to be, oh no, -2. Since we cannot have a square root of -2 at x equals to -1, our graph is still not defined. Okay, so now let's go with x equals to 0. Then here you're going to have 0 minus 1. So again, we're going to have square root of -1. Oh no. So our graph is not defined at x equals to 0. Now let's go with 1. When x is 1, our y value is going to be 1 minus 1. So this is going to become square root of 0, which is 0. So this is telling you that when x is 1, our y value is going to be 0. So, yay. Alright, now let's go with when x equals to 2. Our y value is going to be 2 minus 1. So this is going to be square root of 1, which is 1. So let's plot that. So when x is 2, y value is positive 1. Now when x is 5, our y value is going to be 5 minus 1, which is square root of 4, so it's going to be 2. So when x is 5, 2, 3, 4, 5, our y value is going to be 2. Okay, so let's keep picking more points. I'm going to go with x equals to 10. So then our y value is going to be the square root of 10 minus 1, which is square root of 9, which is 3. So when x is 10, 5, 6, 7, 8, 9, 10, ooh, I just made it. When x is 10, our y value is going to be 3. So it's a very slow moving graph, but I hope you get the idea. It's going to go like something like this. Okay, now let's go with the domain and a range. So let me just write down domain. Again, domain is the settable x values for the function, or this is a function because it passes the vertical line test, where the function is defined. So if you want to find the domain, you want to look at the graph from left to right. So where does the graph begin? Well, graph begins at x equals to 1, and then it's going to keep going all the way towards positive infinity. So in this case, our domain is going to be starting from x equals to 1. Our tail end of the graph is going to shoot up to positive infinity. So the domain is close to 1, infinity. Now let's go with the range. Okay, so again, range is the settable y values where the graph is defined. So you're going to have to look at this graph from bottom upward now. So let's take a look. Okay, so bottom upward. What is the y value? Starting point for the y value? Well, y value starts at 0. And then notice that this tail end of the graph is going to keep going up and up and up and up very slowly, but it's going to shoot up to positive infinity eventually. I'm talking about the y values now. So our range is going to be 0 to positive infinity. Another way to think about is this. Let's look at the graph. Where does the graph begin? Well, beginning point is here. So as in terms of an ordered pair, this is when x value is 1 and then y value is 0. That's our starting point. So our starting value for x is 1, and then our starting value for the y is 0. Okay, now let's look at the end of the graph. Well, it's never going to end, so our x value is going to go to infinity, and then also our y value is going to end at positive infinity as well. So I'm just going to write it as this is our x value, so that's going to go to positive infinity, and then our y value eventually going to go to positive infinity, so that's the y value. So if I look at just the x coordinate, starting point is 1, and then end point is going to be positive infinity. And if you look at the y coordinate, let me see, I'm trying to change the color here. All right, our y value starting point is at 0, and then it's going to end up at a positive infinity. So that's another way to look at it. But if you have any questions, of course, you know where to find me. All right, let's do another one. F of x equals -2 times the absolute value of x. So again, I'm going to make myself a chart. So x and then y equals -2 absolute of x. All right, so let's start from maybe -2, -1, 0, 1, 2, and so forth. Okay, so when x is -2, our y value is going to be -2 times the absolute of -2, which is going to be -2 times absolute value of -2 is +2. So it looks like it's going to go to -4. Let me make the grid first. Okay, so I'm going to plot x is -2. Y is -4. 1, 2, 3, 4. Is that -4 right here? 1, 2, 3, 4. I think so. Okay, so I'm going to plot this point right here. All right, now let's go with when x is -1, then y value is -2 times the absolute of -1, which is -2 times 1, so it's going to give us -2. So in this case, when x is -1, our corresponding y value is going to be -2. So I'm going to plot this point right here. All right, now let's go with when x is 0, then y value is going to be -2 times the absolute of 0, so which is going to give us 0. So this graph is going to go through the origin, and then when x is 1, you're going to have -2 times the +1, which is -2. So when x is 1, our y value is going to be back down to -2. Sorry, -2, I'm invading you. All right, so now let's go with when x equals to 2, +2. Our y value is -2 times the absolute of +2. So again, this is going to become -4. So when x is 2, our y value is going to be -4. So we're back down to here. So for the absolute value graph, no matter what, you're going to have a shape of a V shape. So you're going to be able to connect this with a straight line. Okay, so that's our graph. Okay, so now let's go with the domain and a range. So again, domain is set of all x values where the function is defined. So let's take a look at it. When you find the domain, you want to look at the graph again from left to right. So since the tail end of the graph is going to keep going downward, so let me see. It's going to keep going down and down and down, right? So when x is, let's just say -2, 3, 4, 5, 6, 7. When x is -7, is our graph going to be defined there? Yes, it's going to be defined there. Now when x is, let's just extend it over here. Suppose, okay, completely drawn off the scale. When x is -120, since this line's going to keep going and going and going, eventually at x equals to 120, it's going to hit the graph, meaning that at x equals -120, our function is defined. we could do the same thing towards the positive x-axis. So again, our domain is going to be suitable real numbers. So in this case, we write it as negative infinity to positive infinity. Oops, sorry, this means all real numbers. Okay, now let's go with the range. Again, range is the set of all y values where the function is defined. So again, when you want to find the range, you want to look at the graph from bottom upward. Okay, so if you look at this graph from bottom upward, where is the quote-unquote starting point? Well, since this is going to keep going and going and going, so that our starting point looks like it's going to be negative infinity, and then where does it end? Well, if I keep going up, our graph's going to end at y equals to 0. So our range is going to be negative infinity to 0. So this is going to be the answer here. How are you doing? I hope you're kind of getting the hang of it. You know what? Let's do another one. Why in the heck not? So let's call this one e. Now this function that you're not too familiar with, so what I'm going to do is just draw you the graph of y equals sine of x. And let's just determine the domain and the range of the graph. Okay, this is the ugliest graph ever, but all we're going to do is to find the domain and the range of this graph, or this is going to be a function because it passes the vertical line test. So let's first go with the domain. Again, domain is the set of all x values where the function is defined. So let's look at this graph from left to right, because when you find the domain of a function, you want to look at it from left to right. Okay, so where's the starting, quote-unquote, starting x value? Well, since this graph's going to keep oscillating in the same pattern, the starting point is going to be from negative infinity. And where does it end? Well, again, this tail end is going to keep oscillating. So our x value is going to go towards positive infinity. So again, the domain is going to be all real numbers. So here I'm going to write it as negative infinity to infinity. Okay, now let's go with the range. To find the range, you want to look at the graph bottom upward. Okay, so look at it from bottom up. What is the minimum value for y? Meaning, where does that graph begin? Well, it looks like if I look at this graph upward, our graph's going to start from y equals to negative 1. So that's our starting point. So the y value is going to start from negative 1. And then let's keep going up, 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 up. And then let's find out where the graph's going to end along the y-axis. Well, if I keep going upward, your graph's going to end, maybe I should do it right here. Your graph's going to end at positive 1. So our end y value is going to be positive 1. So I'm just going to box that for the answer. Okay, let's take a look at something different. Example 2, given the graph below, let's find the values of f of 0. And let's go with f of 3, f of negative 3, and f of 6 or something like that. Okay, so let's take a look at this graph. So f of 0 is going to give us the y value. So basically what this is asking you is, when x is 0, what is the corresponding y value? Well, when x is 0, our y value is also going to be 0. So because this is 0, 0, so when x is 0, so this is our x, our y value, because remember y equals f of x, so this is going to be 0. Let's look at f of 3. So this is when this is asking you when x is 3, 1, 2, 3, what is the corresponding y value? So again, this is our x value. Now what's the corresponding y value? Well, our y value looks like it's 3. So when x is 3, y is 3. So therefore, the answer is f of 3 is going to be 3. Now let's look at f of negative 3. So when x is negative 3, this is asking you what is the corresponding y value. Well, looks like it's going to be negative 3. Sorry, negative 3 comma negative 3. So when x is negative 3, our y value is going to be negative 3. Now let's take a look at f of 6. So 1, 2, 3, 4, 5, 6. Okay, so f of 6, when x is 6, our y value is, what is that? 4. So f of 6 is 4. I'm just going to box that. How are you all doing up to here? Maybe we should do another example that looks like this. So let's just call this one A. Now let's take a look at B. Okay, so this is the graph of y equals sine of x. But anyways, let's try to find, oh, I'm running out of room. So let's find f of 0. Okay, so what is f of 0? When x is 0, what is the corresponding y value? Well, it looks like 0 as well, because this is 0, 0. So f of 0 is going to be 0. Now let's go with f of pi over 2. Okay, so when x is pi over 2, what is the corresponding y value? Well, it's right here. So when x is pi over 2, our y value is 1. Therefore, f of pi over 2 is 1. Now let's go with f of negative pi. Again, this is asking you when x is negative pi, what is the corresponding y value? Here's our negative pi. It looks like y value is 0. So therefore, f of negative pi is going to be 0. Now let's go with f of 3 pi over 2. Okay, so now when x is 3 pi over 2, it looks like our y value is going to be negative 1. So I'm just going to write it as 3 pi over 2, comma, negative 1. Hence, f of 3 pi over 2 is going to be negative 1. And this is going to be our answer. So I'm just going to stop here and stop torturing you. But anyways, if you have any questions at all, please let me know. And great job.